Okay, there we go. All right, so let's talk homework last night. Check and see who got their homework done. Brendan, you get yours done, honey?
Oh, he's not here.
Yep, good job. Do you have any questions about it? Okay, there we go. All right, so what about the rest of you? Do you have questions on the homework? You had a chance to check it over, I hope. Do you need me to put up did you get 3 and 9 being no reaction? Did they make sense? Because this is less active than that guy. He's not as good a player, so he's going to stay on the bench. We're not going to put him into the game. Magnesium's a better player than zinc, though. So zinc is going to go and sit on the bench, and magnesium's going to go in the game with the acetate. Okay?
The analogies are really helpful.
Yeah, one of the chemistry teachers that used to teach here came up with that, and it was one of the better, like, I mean, I was like, I've stuck with it because it was an incredible representation of how to do this.
Did he also make up the American divorce?
No, that was me. Yeah.
Students from Spanish Honor Society, Spanish Club, and Blue Ribbon Club, please report to the small auditorium for photos. That is the Small Honor Society, Spanish Honor Society, Spanish Club, and Blue Ribbon Club. Please come to the small auditorium. Thank you.
Okay. Don't they have like a list of like one?
No, I know how to say other languages. All right. Any questions on this top section? Anything not making sense to you? Anything that you're like, I have no idea what she's doing?
No.
Because if you look ahead to what we're doing next week, what we're going to do is we're going to throw these things at you in random order. So I give you potassium and water, and I give you butane and oxygen, and I do that. And you have to figure out what kind of reaction it is, then do all this stuff. So that we take it kind of baby steps, but you got more stuff coming at you. What about these guys? Did that help to do the 2 in front of this? When these are even, start with a 2 here. They balanced like a breeze then, didn't they? Okay. So that's the second half of this sheet. Anybody in here not do the homework? Okay. All right. What about, come on, you can do this. There you go. This side then, any questions on any of those? I'm begging you for questions.
It's okay, we can do 9.4.
Are you just so excited to learn?
No, I just don't want to come.
Okay.
Brendan, are you able to print anything else out at home? Oh, good. Okay. I'm going to email you a file real quick, see if you could get this printed. You're going to need it. Oops, I need to put in your email. Yep, you're getting a new orange sheet, and I need him to have that orange sheet so he knows what he's doing. Okay, I just sent it. All right, so let me hand out the next orange sheet. This is your last orange sheet of the year. Orange sheets indicate that you will get to use these on any test or quiz in here that we have. Okay, you don't get to use yours, you get to use mine, but you get to use one, okay?
Sounds good. What did you get for coffee?
Oh wow, that's a lot.
Did you get blueberry shots like the weird lady that's at 8? They were very weird. Oh, you need to shop the
Oh my god.
No, I don't want this one. Take it back. Take it back. Switch, switch.
All right.
Wow.
All right. So we're going to talk about oh, we have to go down to the bottom of this. I'm sorry. This had a second page, didn't it? It's over here. And then go up towards the top. Any questions on these problems? And I'll get them smaller here in just a second. Or is this the wrong page? Yeah, because you only had 5, right? This doesn't look right. Yeah, this is the wrong page. There, that looks better. Okay, there you go. All right, there we go. That's a good size. Any questions on any of those? Anything that doesn't make sense? Yeah. Okay. Everybody's good? Everybody's happy? Everybody knows how to do formulas now? It's Friday. Everybody should be happy. All right, so we are going to talk double replacement reactions. Remember, this is that messed up scenario where everybody swaps partners. Okay?
Couple swap.
Couple swap, yep.
Double dates on.
We're switching sister wives.
Yep, essentially. All right, so this deals with ions. Are you going to work for me today? Please work for me today. That's why I... Oh, do I have to have it? You know, it helps if you plug the thing in. Just for reference, just so you know.
Okay.
There we go. Okay, here we go. So the ions of two compounds are going to exchange places. One of the products, when we do this, okay, so all of these in these double replacement reactions, they have to be aqueous. And we talked about aqueous, that's in a water solution. We indicate that with AQ. Remember that? Okay. One of the products is usually a precipitate, a gas, or water. If everything remains aqueous at the end, just like it began with, then you have no reaction. Okay? So if no products form, if everything remains aqueous, then you have no reaction, and we just write NR there. Okay? So here's an example where we would have a precipitate formed. We have potassium here, and we have our lead. The potassium and lead are going to swap partners. So the lead is going to go with the iodine, and remember, your metal has to be listed first. Then the potassium is going to go with the nitrate, metal, and your polyatomic ion. Here, you form a gas. The iron and the hydrogen swap partners. So hydrogen ends up with the sulfur, and the iron ends up with the chlorine. Now, notice what's happened here. Over here, we didn't have any subscripts. You see that? When we get over here, we do, because you have to reevaluate your oxidation numbers when you bring things over here. Okay? Ions will stay dissolved in water without a driving force. So they stay aqueous. Precipitates, then, remember, those are called Those are formed. There's solids that are formed during the reaction. We indicate them typically with an S. Occasionally, you'll see this on there. It takes longer and it takes up more space. So this is usually what I use. Okay. As a general rule, the reaction, your metals stay and your non-metals swap partners. Okay. So your metals keep the house and the non-metals switch spots.
Okay.
We're going to use the solubility chart in a minute to figure out what is going to form a solid and what doesn't. There are two things then that spontaneously decompose. So if you get either of these things, you erase this and you write these two things in their place. If you end up with this as a product, you erase this and you write these two things in its place. Now, you do not need to memorize those because they are on your solubility sheet down here at the bottom. See that? Okay. Now, how do we use this solubility sheet? What you do, it works kind of like a multiplication table. Do you remember multiplication tables back when you were kids? I think they still used them when you were in school. Okay. You would find the number over here and the number over here and bring them together, and that would tell you what they multiply out to be, what the product is. Okay. So you find your metal on this side. You find your non-metal over here, and then you figure out what's in the box. Okay. Now, this is the confusing part. The S here does not stand for solid. Yes, it stands for soluble. When you get soluble, you're going to write down AQ. So you may want to write this down in parentheses next to soluble so that when you find an S in the box and you're writing that thing out, whatever it is. So in this case, whatever's way up there. What's in this first column way up there? Bromine? Bromine? Okay. So if you get zinc bromide, okay, it has an S here. Don't write an S here. You're going to write AQ down here. Okay. If you get slightly soluble, that's an SS here, you're going to call that a solid. And if you get not soluble, you're going to call that a solid as well. So again, you may want to write these things in parentheses on your sheet to help you remember what they are. Fair enough? All right, let's keep going. So if we switch over to here, back to my double replacement reaction sheet. Oh, our first example is calcium hydroxide. Calcium hydroxide and phosphoric acid. Does this have oxygen in it? Yes, it doesn't begin with hydro. It's got oxygen in it. So I'm going to change the ic to 8. I'm going to put a hydrogen down, and then I'm going to find phosphate. The phosphate is PO4. This comes with a -3 charge. This is a +1. So I have to have 3 of these for every one of these. All right, now we're going to do our swap. We're going to assume that I tell you guys, don't even look up in the chart these. Just assume that they're going to be aqueous, okay? If they're not aqueous, then we goof something when we wrote the sheet. All right, now I'm going to keep my metals in their house. And remember, hydrogen's acting like, it's your cation. It's acting kind of like a metal. I know it's not a metal. I get that. Now, your non-metals are going to switch houses. So this OH is going to go over here. And the PO4 is going to go over here. So when I bring those over, I need to reevaluate my oxidation numbers. This is a +2. This is a -3. That means that I need 3 of these. I need 2 of these. And I can keep this written like this if I want, or I could change it to H2O. All right. So we have, and if you go to college, I'm sure your professors will not like this business. Okay. So when you're done, go back and change this to H2O once you got it balanced. Okay. That's why you do it in pencil. All right. So now we're going to go back and we're going to try to figure out what our answers are going to be to this. Well, over here, I have 3 calciums. I've only got 1 here, so I'm going to put a 3 there. I have 2 phosphates, so I'm going to put a 2 here so I can get 2 phosphates. Then I'm going to go over and try to figure out how to deal with this guy, and he may already be dealt with. I've got 6 OHs, and I've got 6 hydrogens,
Students
so I need a 6 here.
Sisters Inspiring Sisters, Yearbook and Newspaper Club, please report to the small odd for photos. That is Sisters Inspiring Sisters, Yearbook and Newspapers to the small odd. Thank you.
Her voice sounded kind of wavy.
What?
All right.
She was gonna cry.
Maybe she was
Oh my
nervous.
gosh, you're just a you're so
So
sweet.
now we need to go through and we need to check and see what the status of these are. Okay, so we're going to go over to our chart. We're going to find calcium and we're going to find phosphate. So calcium, and be careful with some of these because some of them do have multiple oxidation numbers like iron. So make sure you're looking for the right one. Calcium only has 1 option though. So we're going to go over here. We're going to find phosphate. Phosphate has an N here. So what am I going to write in for this guy? Yep, I'm going to write an S here. And then this guy, I'm going to write in L for liquid because water is a liquid at room temperature. We're assuming that all of these are done at room temperature. All right. So now we have that guy taken care of. We know that it's going to run for 2 reasons. We know that it's going to run and have a reaction because we formed a solid and also because we formed water. Now, if both of these would have ended up being aqueous, then it would have been no reaction. Okay? Yeah, here's a good one. Number 6. All right, so let's do 6 together. So 6 is sodium carbonate, Na2CO3. This is sulfuric acid. It has oxygen in it. There is no hydro here. So I'm going to change this to sulfate. So this becomes sulfate. I'm going to find sulfate in my polyatomic ion sheet. This guy has a -2. This is a +1. So I need 2 of these for every 1 of these. All right. Now, we're going to keep our metals in the same house. And I know hydrogen isn't a metal. We've already been through that, but it's acting like one because it's a cation. And now we're going to partner swap. So the CO3 is going to come over here. The SO4 is going to come over. Wait a minute. Did I not do that right? I didn't do that right. I didn't swap partners. I kept them in the same spot. Come on. Get with the program, Lippy. All All right, the CO3 is going to come over here. There we go. And the SO4 is going here. But this is a +1. This is a -2. So I need 2 of these to balance that out. This is a +1 and a -2. So I've got to have 2 of these. All right.
We have to still do the thing. Love it. Sorry.
I'm sorry. Oh,
You
look.
said the girl was crying.
I never said that. I said he sounded sad. Like he
He
needed a
thought it was a he.
Yeah, that's how they go.
I said she.
You said he.
I said she.
Okay, so I'm going to look up sodium and sulfate on my chart. So sodium is here. I'm going to find that, and I'm going to go all the way over to sulfate. It says S here. So what do I write down?
AQ.
AQ. Okay. So I'm going to write down AQ here. All right. This is an acid.
Means it's aqueous.
Okay. So all acids are aqueous, but remember, we have a couple special acids down here. And this is one of our special acids. So when you get this guy, you are going to go through. You are going to erase this. And in its place, you are going to write CO2 plus H2O. That is from the bottom of your solubility chart, because this guy automatically decomposes into these 2 things. Make sense? Thumbs up, thumbs down.
Cool.
Okay. Now we need to go back to here. This, it says on there, is going to be a gas, and this is a liquid. They gave you that in at the bottom of that solubility chart. Now we need to go through and we need to balance this. Okay, I've got 2 sodium here. I've got 1 sulfate. We're good there. I got 1 carbon. I've got 2 hydrogens. My oxygens, remember this oxygen is part of this sulfate. We've already counted it, so we're only looking at these right now. So I've got 3 here, and 2 plus 1 is 3. So this is already balanced. Okay, so swap your partners, check your solubility chart, check your oxidation numbers, and then balance. So chromium, I'm doing number 9 with you. Chromium, 3 sulfate. This is going to be a 2, and I've got to have 3 of these. Sulfuric acid is going to have oxygen in it. There's no hydro, so we've got oxygen. This is going to be H2SO4. Metals stay in their own house. And then we swap partners. Is this the same as this?
Yeah.
Okay. Even though the partners swapped, they were identical twins, we ended up with the same thing. Okay. So this is actually a no reaction. And if you end up with a no reaction, don't bother to try to balance it. Don't waste your time. Want me to do another one?
Oh, no, I think we're good.
Yes? Okay. Well, you go and work on your own then, Ben. You got the answer key. Okay, pick one on here that you want me to do.
13.
13? Okay. All right, 13 is lead nitrate, so Pb, NO3, 2. Hydroiodic. Hydro, there is no O. So we don't have any oxygen. So we've just got hydrogen and iodine there. This is a +1 and a -1, so that's taken care of. All right. My metals are going to keep the house. And my non-metals are going to swap partners. So my Pb is going to get my I, and my hydrogen is going to get my NO3. This is a +1 -1, so that's balanced. This was a +2 and a -1, so this needs a 2 here. All right, how are we doing on these? All right, so we're going to assume that everything on this side is aqueous. We're not even going to bother to look it up. Over here, we need to look stuff up. Well, at the top of your solubility chart, it tells us way up here that all acids are aqueous. So we know that HI is going to be aqueous. So we need to check our lead next. So Pb2I is going to come in right here. So this is my Pb2I. It says SS here, which is slightly soluble. What that means is a few of them are going to dissolve, but for the most part, it's going to stay a solid. So we just consider that a solid. So this is going to be a solid, and this is going to be aqueous because all acids are aqueous. All right. Now, will this reaction run?
Yes.
Why?
Because not all of it is aqueous.
Right. Yep. Exactly. Okay. So not all of it is aqueous. So this reaction is running. Right here is what's getting that reaction to run. This is going to form a precipitate. So if we were to mix these two things together in a test tube, it would end up kind of being at the bottom of that test tube, that powder. Okay. All right. So now that we have this done, we need to get this guy to balance. So I see over here that I have 2 nitrates. So I need 2 over here. Now I've messed up my hydrogen and my iodine is out of whack. So if I put a 2 there, that gets that to balance. Good. Let me do another one. Which one? 11. Okay. Okay. Iron bromide. So FeBr2. We've got potassium carbonate. So K2CO3. I'll let you write those down. See if you could swap your partners yourself. Check your oxidation numbers when you're done swapping. Got them swapped. All right, so my iron's going to stay here. My potassium's going to stay, and the bromine's going to move over to the potassium. And the carbonate's going to move over to the iron. All right. Were you able to get that for your products? Okay. So now we're going to go to our chart and we're going to check and see these guys. So iron 2 carbonate. So I've got iron 2 and I got to go over to carbonate, which was right here. And that has an N. And then the other one was potassium. Is it potassium bromide?
Yes.
Okay. So that is an S. Okay. So now I'm going to go back over to my sheet. And on here, I'm going to put an S here. And I'm going to put an AQ here. Will this reaction run? Yep, this guy allows it to run. So since it's running, now I'm going to balance it. I see that my potassium and my bromines are both 2s. So if I put a 2 there, I've got it to balance. Okay, feeling better about them? Okay, so you've got about 15 minutes. I'm going to give you time to work on these. I want you to get together with another person and try to work as seat buddies and work on getting these done, okay? Don't race through them. Talk to each other about them, okay? So if you're struggling, talk to somebody, okay? Brendan, how you doing, honey? Brendan appears to have fallen asleep. Oh, there he is. Makes sense to me. That's good. Okay. So you've got the answer keys. I posted those a couple days ago. Find somebody to work with. Hi.
So it was N, so how does it become S?
So when you get an S on here, what that S means is that it's soluble. So anytime that the chart says a big S, you're going to write AQ behind these guys. Okay?
And every single time we're assuming that these are all AQ, the first
Yep,
ones?
yep.
Okay.
All acids are aqueous. Anytime you get slightly soluble or not soluble, you're always going to write an S.
Okay.
Okay? I'm going to stop recording this.
And then everything else is just the same.
Hold
Like,
on.
You're
Just let
doing
me
the same step.